Our session will look at one of the distributions, which is called the binomial distribution. So you'll also be asked to describe the characteristics of a binomial experiment. So number one, the experiment consists of a fixed number of trials given by n. Number two, there are only two possible outcomes. That's why it is bi. Bi means two. Either a success or a failure. Number three, the probabilities of both outcomes are constant throughout the experiment. And number four, events occur independently. Okay, so we want to now look at the probability using a binomial distribution. But before we go any further, you need to at least understand how we use a combination. So combination is found on a calculator. So let's look at the formula first of all. N combination R. N combination R is given by n factorial over n minus R factorial times R factorial. Now what's this? Factorial is simply you multiplying a number backwards. For instance, 4 factorial is simply what? 4 times 3 times 2 times 1. This one will give you what? 24. 0 factorial is 1. Your calculator also has factorials. I don't know what calculator you're using. How many have a Casio calculator? So you also need to know your calculator very well. Okay. So let me look at the most common calculator, which is a Casio. And I'll take you through how to use the Casio calculator. Okay, so let me just beam the Casio calculator and just show you how to use. So we have the Casio calculator here. So combination is this pattern there. So if you're going to do 5 combination 3, you press 5 combination 3 equals, you get a 10. Can you confirm that? In the case that you don't have a calculator, you can draw a Pascal's triangle with 3 ones. 1, 1, 1. 1 plus 1, you added 2 there. 1 plus 2 is a 3. 3 plus 1 is a 3. And you close with the ones. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. And you close with the ones. 1 plus 4, 5. We have a 10 there, we have a 10 there, we have a 5. You see what I'm doing? I'm simply adding. We have a 6 there, 15, 20, we have a 15, we have a 6, we close 1 and 1. The 7 there, 21, 35, 35, 21, 7, goes on and on. But what I'm interested in is you understanding how to use without a calculator. So 5 combination 3, you locate where 5 is after 1. So you count 1, 2, 3. So the answer is 10. In number combination 0 is 1. 7 combination 0, you go with 7. 0. So this is 7 combination 0. So 7 combination 3, you go to 7. 0, 1, 2, 3. So that's 35. So now let me ask you, what is 6 combination 3? Just from the table. What is 6 combination 3? What is the answer? 1, 2, 3. It's 20. Simple as that. Okay. So any number combination 0 is 1. A number combination 1 is itself. So 7 combination 1 is 7. A number combination itself is 1. 7 combination 7 is 1. A number combination second last number is itself. 7 combination 6 is 7. So 6 combination 5, 6. 6 combination 6, 1. 6 combination 0, 1. 6 combination 1, 6. All right. So this is what is denoted as n combination R. The shortcut is put as follows. So in this case, we now look at the binomial distribution formula. So the distribution formula is given by combination n combination R, or you can use X in this case, and P, put X there, and 1 minus P, you put n minus X. This can also be called Q. Now this is the second easiest distribution that you could ever learn, because you're only given two things. So for the binomial distribution, you need to know that you're using the combination formula. On the P, put the X. On the Q, put the difference between X and N. All right. So you also need to know that the mean is simply given by N times P. The variance here is given by NPQ. And the standard deviation is given by the square root of NPQ. So if you're given a sample size N is equal to 10, and your probability P is 20%. So you need to understand how to calculate the binomial. So help me understand, what is our P? Our P is 0.2. The Q is the remainder. So our Q is 80%, which is 0.8. The two must add up to 100. All together at that point, P and Q must add up to 100. You're never given Q, you're only given one part. Then how do we find the mean? The mean is NPQ. So our N is 10. Our P is 20%. And our Q is 80%. So our NPQ is what? 10 times 0.2 times 0.8, which is 1.6. Now this is not the mean. This is our variance. The mean is simply NP. So rub off this. So these are the mistakes people make. So our NP, 10 times 0.2, is simply 2. The variance is NPQ, which is 10 times 0.2 times 0.8, which will give us 1.6. Then the variance, the square root of 1.6. The standard deviation is the square root of 1.6, which is 1.26. So at this point, are we together? Anyone behind? With what has been mentioned so far? We haven't yet started doing the major calculations, but what has been discussed so far, are we together? All right. So now we've been asked to find the probability x is equal to 0, probability x is equal to 1, probability x is equal to 2, probability x is equal to 3. Let's find the individual probability of the exact figures here. And we are also going to be asked to find probability at most 2, and finally probability at least 2. So what's the probability of 0? So we go here. Probability x is equal to 0. We use first the standard formula and combination x. And here we put our p. And here we put our q. So probability x is equal to 0 will therefore be 10 combination 0. Then here the p is 20%, which is 0.2. The q is 80%, which is 0.8. So the 0 comes here. 10 minus 0 is a 10 again there. Okay, what is 10 combination 0? Remember, n number combination 0 is what? 1. And n number to the power 0 is also 1. So you're simply remaining with what? 0.8 to the power 10. So which is 0.1074. So ideally, leave it to nearest 4 decimal places, 1074. So these two must add up to the top there. So let's try x is equal to 1. So we're going to have 10 combination 1. All right. So here we know we have our p, which is 0.20%, and here 80%. If our p was 30%, he would have put 0.7. This one's the double 1. This one will come there. 10 minus 1, it is 9. So when you add these two, they should tally on top there. So n number combination 1 is that number itself. Remember, 10 combination 1 is 10. 0.2 to the power 1 is 0.2. Then 0.8 to the power 9, you can compute that one. It's 1342. 0.1342. Then multiply them together. Times that, we're going to get 0.2684. Right. It must properly fit in. So I want a lady to lead us through. X is equal to 2. How do we find our combination? What do we get? How do we find that? So it's 10 combination 2. Yes. Yeah, what do we have here? 0.2. And here, 0.8. So this 2 comes here. We have a 2 there. Then what comes on top here? The difference. 10 minus 2, which is 8. So the difference there, then you now compute this. 10 combination 2. You can use a Pascal's triangle, or just quickly go to your calculator. 10 combination 2. Remember, for the first 2, I didn't bother myself to use a calculator because I know the first 2. In number combination 0 is 1, in number combination 1 is itself. But this one here, I can't use my head. So 10 combination 2 is 40 what? 45 times 0.2 to the power 2 is 0.04. And 0.8 to the power 8 is 0.1677. Okay, 0.04 times 45. So we get 3020. 0.3020. So this is the probability x is equal to 2. Lastly, let's try x is equal to 3. Can somebody lead us? What are we going to have here? What are we going to have? Chiloba? 10 combination
We
what?
have 10, 10, 10 and 3. Then 0.2 to the power 3 times 0.8 to the power 7.
Excellent. So we now evaluate 10 combination 3 is 120. So you put 120 there. 0.2 to the power 3 get 0.008. 8 to the power 7, you get 0.2097. Then you evaluate, you get 2018 as the final answer. 0.2018. 2013. Okay. So we have found the probabilities of what? 0, 1, 2, 3. Now, sometimes the examiner would now want to use statistical grammar and ask you to find the probability at most 2. At most 2 means what? 2 and below. So you simply do x is less or equal to 2. And usually probability starts from 0. So numbers less than 2 or equal to 2 is 0, 1, and 2. Arrange them preferably in this ascending order. So what's the probability of 0? 1074. What's the probability of 1? 2684. What is the probability of 2? 3020. So when you add all these, 1074 plus 2684 plus 30, 20, 67, 78. So this is the probability of having what? At most 2. Are we following? That's the probability of having at most 2. But if they ask probability of at least 2, at least means that number and above. So at most means that number and below. So you need to understand grammar very well. So at least 2 means we're starting from what? 2 going upwards. So meaning we're looking at the probability of what? 2, probability of 3, probability of 4, up to the last number, which is n, 10. Now, statisticians have analyzed that this would take you whole day. So you simply look at 1 minus the numbers that are below this, the unlisted numbers. Which numbers are below 2? Probability of 0 and probability of 1. After all the probabilities must add up to what? 1. So if they say at least 2, so if you're doing 2, 3, 4, 5, 6, 7, 8, 9, 10, you're better off just doing 1 minus the unwanted part. So meaning probability of what? 0 is 0.1074. And probability of 1 is 0.2684. Now you add these first before you subtract from 1. So 1074 plus 2684 equals to be 3758. So 1 minus 0.3758. Then that's when you subtract from 1. So 1 minus answer. This is 0.6242. So this is how binomial distribution is supposed to be treated. This is how the binomial distribution is supposed to be treated. So I've already explained on these formulas here, just to explain a few things. Suppose you have a coin tossed 6 times, so your n is 6, and you're asked to determine the probability that you're going to get 2 heads. Now, here they haven't given you the probability, but we know a fair coin has a fair chance of having a head and a tail. 50% can have a head, meaning the other side is a tail. So exactly 2 tails, so 2 goes on the 0.5, the difference 6 minus 2 is 4. So you calculate this. So this one has some hidden information of the probabilities, because there are 2 possible outcomes, a head and a tail in a coin. Let's look at another example. All right, the same question, calculate the probability that you land fewer than 3 times. The head will land fewer than 3 times. So it's talking about the probability of what? Fewer than 3 times. It is 0, 1, and 2. Don't include the 3 because it's fewer than 3. So we do probability of 0. 0 comes there. 6 minus 0, still 6. And number combination 0 is 1. And number to the power 0 is 1. Then just find 0.5 to the power 6. This is probability of 0. Then we do the radical 1 and 2. In this case, the radical is the x. Don't worry. 6 combination 1, we put it there. 5, 6 minus 1 is still, it's 5. So you find 6 combination 1 is what? 6. And number combination 1 is 6. Are we following from what I was explaining, isn't it? Are we together? So this is how we found 0.0938. Remember, put them in 4 numbers, preferably. Probability of 6 of 2, the 2 comes there. 6 minus 2 is 4. Then we combine them, then 344. So we add all these 1, 2, 3, because we're talking about what? Fewer than 3. So when you combine all these, the probability is 0.3440. Okay. So let's look at another question on the same subtopic. Calculate the probability that the coin will land more than 4 times. Remember our n was what? 6. So more than 4 times means 5 and 6. So you can find probability of 5. The 5 goes there. 5 minus 6 minus 5 is 1. So we combine them, we get this. Then here, the 6 is 6 combination 6, and number combination itself is what? Is 1. All right? So, and 6 minus 6 is 0, so we get this. Then we add the 2. We get 0.09 and 0.015. Then we add them, get 0.109. So this is how we find our probability of more than 4 heads. At least 4, you'd have started from 4 going upwards. Are we together? All right, so we'll end here for now. I'll give you homework. Please remember to send the solutions to me. Those of you who started late, you could still join us in our catch-up classes and join the beginners class. Otherwise, this is where we end for now. I'll send you homework just based on what we have done.